Professor, can you see my screen, full screen now?
Yes, yes.
Okay, thank you. I think our time is quite in time, and I will just start record. Yes, I think time is reaching 4 p.m. in Beijing time and 10 a.m. in Delhi time. So I would like to start our session. Ladies and gentlemen, professors, and dear friends, this is our fourth series of innovation seminar hosted by China Delhi Laboratory on Advanced Manufacturing CI-LAM. And today we have a very hot and interesting topic, AI in Industry 4.0. I am today's moderator. I have the English name Jason, but in Chinese I have name Wang Jian. I come from China Science Tech Automation Alliance. And also I am the steer committee member of the CI-LAM summer school organization. Now let's have 5 minutes to have a short introduction about the mission and the activities of CI-LAM. And please allow me to introduce today's keynote speaker and the 4 startup representatives. Or you can see the mission and vision of CI-LAM is here. The mission is to promote and enhance the result of a joint cutting-edge research development, including mutual technology transfer and the commercialization. The vision of the CI-LAM Joint Lab is to be the most effective collaboration bridge between China and Delhi in the area of advanced manufacturing. There have totally 5 founding partners. The first one is the University of Bergamo, and followed by Naples Federico II University. And also we have Tsinghua University. The 3 leading universities are the founding members. And also we have 2 founding members from the industry. One is Companion New Steel. It is a new startup incubator. And I come from China Science Tech Automation Alliance. It is an organization founded by the leading automation and robotics companies around the world. And we have an inclusive model. We have 3 universities, we have incubators, we have industry organizations. And in the future, we would like to introduce more members at other rules and other initiatives, so that we have to reach the model of such a CI-LAM business architecture. The CI-LAM action plan, we have to do advanced researches together, and we have to develop standards, international one or local one, or even the national one. And we would like to provide strategic services to startups and SMEs. You can see that even today we invited 4 startups from 2 countries. And we are trying to advancing the demonstration and the realization of the relevant technologies. And also the cooperation between the 2 countries will be our final target. So that we want to set up advanced manufacturing clusters between China and Delhi. Yeah? And here are some pictures you can see it take from the events we held in passing 3 years. You know the CI-LAM laboratory was initially set up in 2017, and now 3 years have passed away, and we have many events, seminars, and summer schools, mutual visits, and many mutual dialogues. So that we are most active in advanced manufacturing areas. Okay, also there are also some pictures. And now we are in the series of CI-LAM Academy. The whole name of the series is The Power and Future of TechX. And we are trying to develop the series of the seminar into two parts. One part is towards the graduate and PhD students from universities and colleges. Not only include 3 universities, but also we can invite or introduce other students from other universities. And as far as I know, for this time, the total students could be reached 200 or 300. So it's a big size. Now we are in innovation webinar series. This webinar series is intended to professionals, managers, and researchers in the industry. And we try to promote and set up an exchange bridge between China and Italy advanced manufacturing areas. Here you can see the program of today. The topic is AI in Industry 4.0. I would like to introduce the keynote speaker from the University of Naples Federico II. He's the professor of Carlo Sansone. So Professor Carlo, could you show your hands to our audience? Yes, thank you so much. And followed by the keynote speech, which is about 20 minutes. You have 4 startups. The 2 red ones are from China, Dr. Li Miao, and also Dr. Jin Wenjing. Also, we have another 2 Italian companies. All these 4 companies are in the areas of AI, especially in industrial applications. And finally, if we have time, we would like to have a short Q&A. It's about 10 minutes. So the overall time period of this seminar today is about 1 hour, okay? So now let's have a warm welcome to our keynote speaker, Professor Carlo Sansone, to give a speech. You can see he has a huge network in research, and also I think he's also for many papers and books and other publishers. So welcome. I would like to give the screen back to Professor Carlo. Okay.
Okay. Thank you very much. So I can share my screen. Okay. So this morning in Italy and this afternoon in China, I speak about AI in industry 4.0. So this is my affiliation, and this is a small agenda of my speech. First, I'll talk about different AI topics. Then I'll try to give you a state of AI in industry in 2020. And then I'll illustrate some case studies that we developed in our department in collaboration with other companies. So what about AI topics? Well, AI is a quite broad field. In this period, maybe most of the application comes from the area of machine learning and in particular of deep learning. But anyway, we have a lot of topics in AI which are also of interest in industry. For example, I'll show you a even if quite briefly, an application using natural language processing for set up a chatbot in health application. So AI topics can be seen as I wrote, a connected graph of very different research areas. There are also several links with robotics. Here I use the term cognitive robotics, but anyway, there will be also another seminar that focus especially in robotics. So there are several topics that can be of interest, as I already said. Some of that are mainly, or maybe more research topic than applicative topics, but anyway are obviously of interest because they can be also used in a very specific application. So maybe nowadays, as I already said, when we can write something about an artificial intelligence system, in most cases, this kind of system uses maybe a computer vision, some computer vision algorithm or method, and maybe use a sort of deep learning based system that can provide an insight about a specific problem. What about, oh, sorry, okay. What about the possibility of giving a state-of-the-art in industry? Well, very recently, a company named Appen has its headquarters in Australia, but also has offices in USA and also in China. Appen is very active in the field of artificial intelligence, in particular machine learning, in the sense that they provide the data for a lot of the company, labeled data, and also they are active in producing data of significant quality for training machine learning based system. So this year and also in the previous year, they produced a state-of-the-art, a state-of-the-AI report with a focus in industry, in the sense that they surveyed 374 companies in the months of April and May 2020. So this report can be seen as a very recent state-of-the-art, and what are the main takeaways that we can have from this report. This report is can be downloaded from the web. Well, today about 3 out of 4 organizations say that AI is critical to on their own business. Anyway, half of this industry feel that their organization is behind in their journey towards a very significant application of AI in their business. Another significant news is the budget devoted to AI is doubled year over year. So there is a significant interest in investing a very significant budget in AI application. Another very important point regards the use of responsible AI. There is also in the scientific community a significant, and also in industry, a significant exchange of ideas about the problem of biased AI. So the ethics to up a responsible application of AI. Even if, as I already said, more companies are declared that they have thought about the use of responsible AI. Only 1/4 of companies say that unbiased AI is mission critical. So this is a point to be addressed. Another important point regards the data, in the sense that 3 out of 4 organizations update their AI models at least quarterly. So this is very important, because once again, data is critical for AI application. And so when we have a significant amount of data, and also data of good quality, because sometimes the problem is about the quality of data, then for industry this is a very important value. There's still some gap between the business leader and technologists, even if this gap is smaller with respect to the previous year. In fact, this report contains also some comparison with respect to the same report of the previous year, 2019. Finally, there is a focus about the coronavirus, so the COVID-19, and in this case, a good quantity of a good amount of industry, about 2/3, do not expect any negative impact from COVID-19, but in some cases they also have more business due to the coronavirus. So now I just show you some pictures, some graphs that comes from the same survey. As I already said, the number of industries that retain that AI is critical to the success of the business improves year over year, and about 3 industry out of 4 declares that AI is really critical for their business, and this amount increased with respect to the previous year. Also, regarding the budget, there is a significant part. There is doubled the number of industry that allocated a budget greater than $5 million, and also the percentage of industries that allocated a budget in the range 500 euros, 5 million euros is doubled. So also this is a good news about the use of artificial intelligence in industry. What about the tool and the frameworks used nowadays in industries? Well, an important point is that all the tools, all the frameworks improved from the previous year to the current one. And at the moment, Azure is the most used tools in industry, and also Google Cloud is very used. For example, there is Colab that we also use in our university, in our lab. And as regards mainly the problem of NLP and conversational chatbot, IBM Watson is very used also, and also Amazon with AWS is quite used. There is also a significant part of industries that also uses Salesforce. What about the problem of risk management, ethics, and governance when using AI? Well, when the company developed a very used application, so when they have global products, they are significantly known that there are several problems that needs to be addressed, in sense that, for example, 62% will no the artificial intelligence, the perception that ethics and also governance problem are significant decreases, while the management problem is typically the most important one for all the industry. Another interesting point that regards the, let me see, a responsible use of the AI. As I already said, in this last year, there is also scientists, but also politicians are aware that the use of artificial intelligence can also some abuse in some sense. And at the moment, unfortunately, there is bias law in application. There is likely a quite significant of the interviewed people that known that it's very important and also is mission critical the use of unbiased AI and the fact that data diversity is present in their AI application. What about the data? This is also interesting since, as maybe we can also see from the different application that we see also on the market, there is an increasing use of video. For example, from last year, there is double the number of application, or at least of company that that process videos, and there is also an increasing number of audio application, while the most used kind of data is still text, even if the number of a company that developed AI application using text is slightly decreasing. Also, the use of time series is significant, but there is also a decrease in this sense. So maybe audio and video represent at the moment one of the most important source of data for AI applications. Another important point is what is the bottleneck for initiatives or projects linked to AI in industry. From this point of view, there is some cases in which industry have no AI initiative, but anyway, it's quite interesting to see that the most critical point is the lack of qualified people or of technical resources. So there is need of investing in teaching and in training people so that they can be employed in the industry in order to develop significant AI application. Obviously, another point which arises is in some cases the lack of data. This, as it can be quite obvious, there is a problem most for technologists that obviously work every day with data, while business leaders not think that lack of data is a very significant problem. On the other hand, the management of data is perceived both from technologists and business leaders as a bottleneck, as a problem. So, in summary, the lack of qualified people is perceived as the biggest problem for developing other and more efficient AI applications in industry. Finally, what was the impact of coronavirus on the market? Well, there is not a significant impact, in the sense that only 8% of the 8-9%, 8 in case of technologists and 9 in case of business leader, perceived that coronavirus was a significant problem that led the application of the development of AI application in their context. On the other hand, in some cases, about 1/5 of cases, there is a significant acceleration of the developing the production of AI system due to the coronavirus. So there is, in some cases, it was an opportunity instead that a problem. Obviously, it depends on the specific market of the industry. This ends this very brief report about the current state of the art in industry. As I already said, this data comes from about 400 industry that was reviewed in the previous months, and it's quite interesting to see, and also it offers some interesting key points to talk about the use of AI. Maybe one of the most important points regards the use of responsible AI, which can be a factor in maybe in industry, and as we said, also the lack of qualified people is also important for us, in the sense that we are to invest in training and teaching in this sector. We have also seen the picture of my group at Chieti. We are quite active in the field of biomedical image analysis, with several collaborations with our university and also with the research center and also company. And also some of us has a very strong background in multimedia system and also in big data application. So I just conclude by showing you a couple of applications. In this case, this is a problem that comes from in industry. They have the problem of improve the automatization of their industrial process. In particular, during a stage of their industrial process, there are bars that are deposited on one of 3 benches that are in a stocking area. They want to recognize, this industry need to recognize whether a given bench is empty in order to fire a successive automatic task in an automatical way. So the problem that arises, for which we used an artificial intelligence approach. In particular, we used a deep learning model. They have 3 different cameras, one for each bench, and the problem is to automatically detect if the bench is occupied or not. In this middle left image, we see some example of empty benches, and in the right image we can see case in which the bench is occupied. In some cases, it's not very easy to detect the presence of something on a specific bench. After several trials, the solution we developed was based on deep learning model. In particular, a quite complicated strategy we used, in the sense that we give rise to an ensemble of different classifiers using a sort of stacking procedure, in the sense that we have 2 levels of classifiers. A first level in which we have a quite standard convolutional neural network that as an input a crop of the image, and as output the probability that the bench is occupied. On the other hand, we developed 3 different anomaly detectors by using a deep autoencoder, one for each bench, because there are different illumination condition for each bench. So we found that there is better to have a different detector for each bench. After these first level classifiers, the output of the specific detector with the label of the bench the image comes from, and also the output of the convolutional neural network are merged and to regressor. This model, in this graph, we also I also report in more detail the configuration of the anomaly detector. This model has a sort of perfect classifier on a number of images that are reported here. And we also obviously compare this solution with more standard solution that used a sort of simple logistic regressor, but also a quite standard CNN. In particular, CNN is the deep net that is part of this more complex system, while the performance of a single anomaly detector is pictured here. And by properly fusing anomaly detector and CNN, we reached a sort of perfect classifier. Obviously, when we use this kind of approach in a real world case, there are also several other aspects that we have to take into account. For example, the prediction time, in the sense that our stacking model surely perform better than a quite simple, for example, logistic regression, but there is about an order of magnitude difference about times. So obviously, when we use a quite complex approach in an industrial case, we have also to take into account at least some other things like time. On the other hand, there is not a very significant difference about times from the solution that uses a simple convolutional neural networks with respect to the approach we proposed. In almost all the cases, the use of GPUs obviously reduce the time for processing a single symbol. Finally, I very briefly illustrate another case study. In this case, we have to set up an intelligent medical recommendation system, in the sense that another company asked us for setting up an intelligent medical recommendation system that can be seen as a system that can be designed to interact in an autonomous way with the user by using a sort of chatbot application. It's using other very simple app. The difference from with respect to the previous case is that in this case we mainly use text. So this is the solution we developed. There are several technical aspects in this slide, and also the technological stack we used. Mainly we used the conversational engine of IBM, Watson, and so the patient can interact or by using the chatbot interface, also by a mobile phone, for example, but also by interacting by a web app interface. And we developed a quite scalable architecture, and this is a snapshot of a conversation with our system. The interesting fact is that this chatbot was developed in order to suggest a prevention pathway, in the sense that by using data that came from the company, we were able to predict a possible prevention pathway for a given user by processing its answer. So the chatbot makes some question to the user, for example, where do you live, and also other simple question. And by processing its question, the system was able to detect the most similar prevention pathway with respect to the single user. So in this case, we also applied a machine learning model in order to classify the user on the basis of its answers to a specific possible prevention pathway. Okay, so this ended my my presentation. Obviously, I tried to illustrate just two case studies developed by us by considering both images and text that as we seen are two of the most used data source for AI application. So thank you for your attention.
Thank you so much, Professor Carlo, for your great presentation. I think you firstly introduced interesting data from the survey, and then followed by two use cases. One is for industrial manufacturing process, the other is for medical services, right?
Yeah,
so I think
right,
it's very,
right.
And I see that your research area is in the medical and also bio neural network areas. So I'm looking forward to have a further discussion with you regarding to your in-depth areas. Okay. So if there's any question from the audience, I would like to encourage you to ask question to Professor Carroll in the end, at the end of this session. That will be followed by 4 startups. Now we come to our next program. I would like to introduce Mr. Let me share my screen. I would like to introduce Dr. Li Miao. Okay, you see the screen. Yeah, Dr. Li Miao is a founder and CEO of the new startups named Cobot. In fact, their companies not only develop hardware Cobot, but develop the intelligent or smart operation system for Cobot areas, and also develop some very high-tech vision and sensor, and also assembly to solve the problem from the industry. So very interesting and very technology and software driven company from Cobot. Now welcome Dr. Li Miao. Okay, Li Miao, you can share your own screen now.
Okay, can everybody hear me?
Yeah, can you show your video also so that people can see your face?
Okay, where to open my video? Sorry, where is okay.
Good. So just adjust the angle of your camera so that we can see your full face. Okay. Right. Good. Start.
Okay.
Please.
So hello everyone. It's my great pleasure to share this talk with all of you. So I'm Miao Li from Cobot Technology. As introduced, I did my PhD at Switzerland in EPFL with Professor Aude Bilad, and basically I'm working in the area of robot learning, especially robotic grasping and manipulation. And during my PhD, I already have a lot of experience to work together with Italian professors and a lot of university and institutes there. And since actually 2016, July, and until this month, it's almost 4 years now, I moved back from Europe to China. And the basic motivation behind this is that we noticed during 2016, and it's a changing point that a lot of people will getting old in the next 20 years. And according to some statistic, by 2040, actually 1/4 of the people will above the age of 65. So we think this may be a huge opportunity actually to use the robot to replace a lot of these human neighbors. And we also noticed that actually almost like 80% of this job are done using the hand, eye, and brain. And actually the current industry robot, especially this very giant industry robot, is not so actually it's not so proper or so useful for this kind of application. So we try to build some underlying or very fundamental platform that actually can empower robots with the ability to see and to manipulate. Actually is to replace the human hand and eye. So we developed an intelligent industry robot operation system called Cobot. This is not a simple replacement of ROS like the robot operation system using in academia. It's actually built from scratch, I mean, from the very low level. In this operating system, we have a lot of this IndustriLink. It can connect to different cameras, including 3D camera and 2D camera, a lot of this force torque sensor, and the different types of robot include ABB, KUKA, FLAC, and all these different robots. And also a lot of different ND effectors and industry controllers. And built on this, we have a lot of these different intelligent algorithms. And this algorithm including like a force torque controller, and the intelligent motion planner, and also different vision algorithm. I will show a bit more of this intelligent component later. And on this, we have a development environment. It's like a IDE. And on this IDE, people can use a simple GUI, simple GUI to develop different applications. And currently, we are mostly working on grasping application and polishing application, and also assembling application. And with this, actually, with this intelligent operation system, we can develop a lot of applications in different domains. Currently, we're working on in this food industry and also logistic and medicine area. But also, we have a lot of other very nice examples in this medical 3C industry and also nuclear power and so on. The basic connection or basic structure of this system is like this. It connects with this 3D cameras, and also it connects with these different motor drives. And on this, it can connect with a lot of different robots. And from the information connection, it can connect with this warehouse control system, also with this MES in the manufacturing, and also like this information system in the history. And with this, actually, people can connect almost all the devices in one application without knowing a lot of these low-level details. For the intelligent components, as I mentioned, we have this model selection. Actually, this is already like one a difficulty for a lot of developer. So the first pain point is that actually the robot types, like they depend on a lot of factors, and they need to ask a lot of people which robot type they should select. But in our system, we can like intelligently recommend for your application what type of robot is best for your application, and also for the layout. Should the robot place in the center of this station, or in the edge, or in whatever angle or orientation? And also it has a built-in calibration, hand-eye calibration, and also this teaching demonstration only like this like this robot dependent. For the simulation, it's offline simulation, and all of these are already built in. For other like a more intelligent component, it will include it already includes this 3D vision. Actually, this is our built-in 3D camera. We have this is the only hardware we have built, and this is a structured 3D camera. It can provide a quite nice point cloud, and this is the point cloud. And also based on this point cloud and the 2D image, it also have a 2D image. We can give a very nice grass planning algorithm, and also based on this grass planning algorithm, we can like simulate this different grass. I think this is like a coma robot. And also for this palletizing, it can recognize different type of these bags. Until now, we can deal with like more than 20,000 different kinds of SKUs, and we think and we believe this is quite important for industry application. To detect like one SKU is not so difficult, but if you can detect like more than like millions of different SKU, and then your application will become scalable. So this is very important. And of course, we also include a lot of these deep learning components, especially we call it robust AI, and to differentiate with the traditional like computer vision AI. So we need to use our stuff in the industry, and this is quite different in the routine. And we need to ensure that our solution, the value solution, it will run in this production line for the whole lifetime, and then it should ensure the stability, the robustness, and also the reliance, and so on. I will just skip this introduction of the camera, and also this some application for the grasping, and I will just showcase two, I think, more interesting examples. The first one I think is a very famous example, like for us. Actually, it's also the first example we built using our operation system. Is the mushroom sorting system. Actually, for this mushroom, and typically it is the typical food in China and also in East Asia, and people eat a lot of this mushroom. But actually, they are grown in the same dough or in the same place, but with different types. And there are a lot of people, actually thousands of people, are sorting this mushroom according to their texture, their color, and different features. And this sorting, actually, the criteria for this sorting is not so strict. So they will have a lot of this inconsistency, and then the end customer will not have a very good feeling about this food. So we actually use a deep learning system to sort this mushroom according to their different features. And also, more important is that different customer, actually different factories, they will have their own different classification criteria. So actually, we are actually build something very similar as this autoencoder decoder structure. We actually try to use a deep learning structure to learn the feature, this different feature of these different mushrooms, and then we combine this different feature to build another classifier on these features, and then this can directly link to the criteria of the end customer. This is a comparison of this final system. We can see that before there are a lot of humans doing this, and now we have a very clean and very nice working place for the machines that are working on this. Actually, this place is located in Hubei, not so far from Wuhan, and actually during this COVID or COVID-19, a lot of factories, like the traditional factories, they are not allowed to go back to work because of this virus, because there are a lot of people in the same room. But for our customer, they use this machine, and with this deep learning or AI-based sorting system, they are allowed to open this. Of course, they are allowed to open the factory because there's not so many people out there. And this is some more example that we have deployed in different factories. We can see that it's quite fast. Actually, this is also one of the challenges, as the previous professor also mentioned, that we need to ensure that actually the detecting system should work in real time. So for example, for this, every 100 milliseconds, we should detect one mushroom here. So but there's no guarantee that your deep learning system can actually work in such a quick manner. So we actually did a lot of this deployment stuff here. And another example is more related to the I think it's more related to this talk, is the example for the detecting of the chocolate. And this is the project we work for Ferrero, and I think this is a company originally from Italy. And for this, I think a lot of Italian people and European people like this Kinder chocolate. For this Kinder chocolate, actually, they have a lot of defects like this, and have more than 2 balls, have a lot of, have too much sugar and different defects. And we use the system, is also a vision-based system to detect this. And this vision system, we can deploy the whole system within 1 month because of this operation system, because of our Cobol-Sys, because everything there are already modular and component. This is basically the working the workflow for the whole system. We have this whole stuff here, and then we extract the different individual figures, and we compare this with using both traditional computer vision and also the deep learning based detector, and then we combine the result together to see if this Kinder is good or not. And the final system actually is something like this. I cannot show more details about the system, but actually this whole system are deployed in China. Also, we are going to deploy it also in Italy. So this is something like the final example. And also for this cobalt AI-based detection, we have also showed this in a lot of other different food, and also for the toy of the Ferrero. And I think this is very nice example. And finally, I would like to show one video about another example about the grasping example. So this is example that actually we use for Cainiao Logistics, which is one of the biggest logistics company in China. So this is a warehouse. We also built a grasping application on this. This whole system can grasp more than 4,000 different SKUs. And the total cycle time, and we can see here, actually is around 4 seconds. Yeah. This is actually also the first example in the world. Actually, the robot can grasp different SKUs and without registration. So basically, the robot should recognize these different SKU or different object in real time, and also to place it in the correct place. And the more challenging thing is that there are so many SKU, and every week they switch like 10% of the SKU. So the robot should learn to adapt to the new scenario. And also here is a quick adapter that to change the end effect. I think this is the end of my talk, and we can discuss more. And after this, the whole event, I think. Thanks.
Okay, finished, Miao?
Yes.
I think also you spend too much time, but I would like to give you the right to show the amazing examples and applications. They are all very, very, very interesting for me. And also I learned you have successful applications in food industry, but this is my first time to learn to see the real application, right?
Yes.
So it's very good. Yeah, very good. Thank you so much. And now I would like to change Italy startup. He's come from, so yeah, the company name is AI Set, and Daniel Gamba is the founder and CEO. And it is also a new startup, a spin-off company from University of Bergamo. So let's see what's the application, what some AI solutions that come from AI set. Okay, now welcome Daniel, and please save your time. Okay.
Thank you. Yes, please. Okay. I will just share my screen. Thank you very much. It's a pleasure to be here for me. It's really interesting to the application I just saw from Carlo and from Cobot Systems is really interesting for us. Okay, this is the team of iCent. We have a couple of PhDs and researchers from Bergamo and scientists from Italy, and we develop AI and machine learning for different applications in industry. These are some of our partners and of our company we work with. We work with ST Microelectronics, University of Bergamo, Bergamo School, Chamber of Commerce of Bergamo, and a couple of consulting companies like European Ambrosetti. We also have a spin-off of our startup that is FaceOn, is a face recognition algorithm we developed a couple of years ago, and that we have spin-off to sell vertically. So we work mainly on 3 different data types that for us are represented. So one, I have a person which has specialization in these fields, so vision and all the algorithm applied to vision, images, and videos, time series for data in time and text. And we work mainly on 3 different sectors: the manufacturing industry, mainly for control and optimization, the security and defense, and the biomedical sector for some R&D project we're involved in. These are the main research and development areas we work. This for us it's really important to advance technologically, even for a couple of our applications. So Bayesian and deep neural network is one of the main topics for us, as much as anomaly detection applied to Bayesian neural network, and the synthetic dataset generation for the application where we don't have enough real-world data, and ethics and explainability, like Carlos and Sone. It's really important for us, especially in the defense, obviously. So today I'm presenting you our latest project in the manufacturing industry. We have a couple of clients in the plastic manufacturing process, and we named the project Chandra X because we also use different wavelengths of light to address the difficulties they face. Their main concern is about the collection of enough data related to the defects they present. It's a problem in the industry that some defects, but very or destructive or unacceptable in any way. So collecting enough data to train a classifier is not an option. And we worked really strong on the anomaly detection derived from deep autoencoder, generative adversarial network, and all this kind of technologies to train models just starting from positive data. We only collect pictures of products that get out of the production line, and we train our AI in line to address, to understand which is the way. Once we have enough confidence of the performance, we get the AI and we move it to production, and it starts selecting the right from the unknown example. This is just one example of our client. The system we are actually in production, and have 98% in precision of the true and right defect, trial and right samples, and 100% of the discharge of the rejection rate on defects that are labeled as anomalous for us. So this is Chandra X for us. It's just a project I am presenting today to keep my attention as short as possible. And this is mainly the acquisition and training of an anomaly detection model applied to real running production line, and all the analytics we later approach, do on the results of this kind of application. For me, it's just this. I try to be as short as possible. So Jason, it's, I hope I stayed in the time you can.
Okay, thank you so much, Daniel, a young guy from Bergamo,
Yeah.
and amazing presentation and applications. Maybe next time I would like you to show another example for how to deal with the
clearly in the defense sector,
yeah,
we can
time series.
something.
Yeah, the time series problem is
the time series is interesting for us. Yeah.
Very interesting. So next time we have more chances in future, I think. So thank you so much. Yeah, very good. Now we would like to introduce the third one of today, who is also had been at our forum last time. She is Wenjing Jin, yeah, who is a very beautiful lady, come from Cyber Insight Corporation. So let's welcome Jin Wenjing to have his show. Okay.
Okay, thank you.
Please also to note it to save time. Okay, please.
Okay, sure. Okay, good afternoon. My name is Wenjing Jin. Thanks to Dr. Wang. Thank you for inviting me. Today I'm going to share a presentation on industrial AI for smart manufacturing applications. A quick introduction about myself. I received my doctoral degree from IMS Center Intelligent Maintenance System from the University of Cincinnati. My advisor is Professor Jie Li, and he's the global academic leader in industrial AI. He established the IMS Center. Now it's the Industrial AI Center since 2001. And after graduation, I came back to China, started the startup company, Cyber Insight. I'm now the chief data scientist. I received the honor of SME 30 under 30 for recognizing the future leader of the manufacturing. Cyber Insight is a spin-off company of IMS Center. We aim at landing industrial AIs for the industrial to achieve the worry-free industries. We start the team with talents of multidisciplinary capabilities on the domain know-how, AI modeling, and edge computing. Half of the co-founders are from the doctors from IMS Center. We set a goal for ourselves. We will land 100 worry-free lighthouse cases in 10 years, definitely with the help with other partners. Industrial AI is to lend AI techniques to industrial applications. So it requires the interdisciplinary technologies. We define it as the AT, analytics technology, DT, data technology, and PT, OT, platform technology, and operation technology. And as far as we know, the data analysis for industry is quite different from the social network. For example, in the industrial applications, the bad data quality, like broken data, the different applications, all of these issues are quite common in industrial applications. But all of the people, the engineers in industry, they require the AI model to have very high accuracy. So you will find it's really hard, or AI modeling is very difficult in industry. So when you are trying to implement an algorithm or AI model for certain scenarios, we will think a couple questions. First, what problems am I going to solve? And what algorithms do you think you can propose? And is the model accurate enough, or the model reliable enough? So these big challenges in the industrial AI modeling for the industry is the automation, the model quality assurance, traceability, risk management, and the feedback cycles. So that's why we developed this framework, start from the data to model and to the applications. We want to propose this cloud-based framework and platform for the life cycle management for AI applications. That's what we call model ops life cycle infrastructure Molifactory. This Molifactory, we borrowed these ideas from the software engineering. We can leverage and extend the principles of the software lifecycle management to AI pipelines. So in this Molifactory, we can create the model and manage the model and update the model. We can we can guarantee the model accuracy and the reliability. Eventually, the model will become more and more adaptive to the real applications. They can better serve the applications above to the end users. So in the following slides, I'm going to share two case studies how we apply AIs for the industrial applications. The first one is from steel manufacturing. You know, the created and it's very consuming. For example, the blast furnace gas is a type of a bypass product from the iron making process. But the BFG, it can be recycled by the power plant in a steel factory. But currently, most of steel factories in China have much higher emission rate comparing to those steel factories in developed countries. For example, if this blast furnace gas is generated more than the power plant can consume, it will cause a lot of, it will increase the gas pressure in the pipeline. The worst case, it could be explosion. But the shortage of the gas, it will cause the rolling process to shut down. That's why we need to find the balance between the generation and the consumption and find to maximize the energy recycling. So in this case, we first predict the BFG's generation in next, like in short term, 5 minutes, or in the long term, like 1 hour. Based on the prediction, we use the optimization algorithms to dispatch the BFG to the end users. Then we can find the best way to balance the generation and the consumption. This case, the steel inside helped the steel factory to avoid the production downtime, and also to help them to reduce their emission rate from 5% to near zero emission, which is roughly saved like 23 million per year. And the other case is from the Foxconn light-out factory. They call it a light-out factory. The ultimate goal of light-out factory is to reach waste reduction, work reduction, and worry reduction. In this factory, it has smart supply chains, the automatic manufacturing production lines, AI defect detection, and the data analysis for the decision support. So we will find that they have a very important missing part. That's the key for the entire factory. That's how we monitor the machining process. So when the cutting tool or the machine tools, the tools deteriorate when after repeated operation, the tool wear will affect the product quality. For example, replacing the cutting tool before it hit the end of life will cause a lot of huge waste. But if you replace it too early, it would cause the product defect. That's why we need to find, we need to use the online monitoring system to predict the remaining useful life for each cutting tool. So we can maximize the life tool, and based on the prediction, we can optimize its tool changing system and optimize their maintenance system. Here gives an example for the machine tool health management and the tool life prediction algorithms, starting from the data acquisition, like sensors or the controller signals. We process the raw signal at the edge. We use the edge computing and to extract the features, fuse the feature to health value, and based on this health value, we can monitor all of the equipment or all of the machines in the shop floor. So we can know what's the load for each machine and optimize your scheduling and the maintenance scheduling too. In this system, you will say the machine side gives was implemented in this light-out factory. It helped to predict the cutting tool remaining useful life, and we can. This system helps to reduce 60% of expected downtime and improve the yield rate. So in 2018, Foxconn received the Lighthouse Factory Award. And thank you for listening. This is the end of my presentation.
Okay, thank you, Wenjing, for your great presentation. I think you showed us several use cases, not only in the machine level, also in the full production level, and also there are some example from process automation area.
Yes.
So it's amazing. Okay, I think that from these two Chinese startups, we see the AIs not only in embedded machinery level, but also in platform and also on cloud level. So I hope that these two startups can show a completely full picture of the industrial AI, so-called industrial AI. Okay, thank you, Wenjing, for your second performance. Now we come to our last one, which is from Italy. The company name is edugo.ai. And we welcome the CEO and founder of GUCP to give you a speech. Thank you. Yeah, welcome.
Yes.
Please.
Thank you so much for the introduction, and thank you so much for inviting me to this conference. I would like to share my screen so I can share the presentation with you. Can you see my screen? Okay.
Yes.
Okay, I am Giuseppe Tomasello. I'm the founder of Edugo AI, where we build technology to learn languages faster. I'm Italian, but I'm based in Shanghai and Hong Kong. So our company is international. But right now I'm in Italy because of COVID-19. So my background is I studied the industrial engineering in University of Bologna in Italy, and then I have a triple degree from University of Bologna, from Huadong Ligon Dashi in Shanghai in China, and from ICM Business School in France. So since I've been past 5 years in China, I've been founding different companies. So recently I've been in this list of the 30 foreign entrepreneurs in China. Also won the first prize for the AI Big Data vertical for the best startup showcase between the Italian government and the Chinese government. And I'm really active in the Chinese ecosystem as such. Recently, right now is happening the World AI Conference in Shanghai and being invited as a guest. So we also have AI research partners from 2 Italian universities. The first one is from University of Catania, where Concetto Scampinato is a professor of machine learning and AI. And is together with them, we're building our avatar, which I will show you in a moment. And with a startup from a spin-off of CISA, which is a University of Trieste. In the north of Italy, we are building and doing research about NLP, so natural language processing. So what's the problem we're solving? We're solving the problem of efficiency and effectiveness for language learning. So traditional methods for learning a language takes too much time. In fact, if you want to learn Chinese, like I do, it takes 2,200 hours to achieve professional proficiency. So it's a really long journey, and many people give up before achieving professional proficiency. And the main reason is because we lack of personal personalized learning. So each one of us has different objectives. For example, if I want to be able to do this presentation in Chinese, I need to learn really specific content to be able to deliver that. And this personalized content is really not accessible right now. So that's the reason why we build our AI to solve this specific problem. So here on the left, you can see you can have one of our platforms. You can have a video call with one teacher, and during this video call, basically the video call is recorded, and then our deep learning model is processing the content of the video call and having semantic understanding of what's actually happening during the conversation, and moreover also saving the mistakes that the student is making during the call. And after the call, our system will basically process the content, and then will generate tailor-made content that is completely customized to the specific key language points that the student needs to learn. By doing so, we're collecting a lot of data, and these data are now feeding our what we call augmented AI teacher, because we have all these expert tag data, because those teachers are actually tagging the data and they are expert in the language side. And so this way we're able to build this avatar that it looks like your teacher, but is powered by AI. And in this way, we can also decrease the marginal cost of having an online lesson, and we can increase penetration in the low-income markets. So I prepared this short video to show the technology in action. So one of our technologies is a video lesson powered by AI. So the first step is to go in the platform, and you basically can connect to a teacher. And here, basically, we also built we also built some technology that can be also used for teaching during the class. So it's really specific for language teaching, such as integrated speech to text during the conversation. And the step 2 is like magic. Our AI system then will process the content and will give statistics about, for example, the student talking time and teacher talking time, and then all the AI generated linguistic content. So the teacher doesn't have to do any work. It's AI that is basically creating automatically. And then the third step is that the student can actually go and practice the personalized content. So in this case, for example, the student had the problem with pronunciation, and we generated an exercise that is specifically to fix the pronunciation, but we can generate exercises for different kind of mistakes the student is making. So right now, actually, our company is growing pretty fast because of COVID-19. Many of the language schools around the world had to digitalize. And so our solution is actually made specifically for language school to go online. So we're building white label solution for them. Right now, our solution is available for Chinese, English, and Spanish, but other languages are coming soon. So thank you for your attention.
Okay, very interesting presentation. Also, your application is, I think you have a very huge blue ocean market in China, especially people all spend a lot of money and energy try to learn English or foreign language for their kids. Okay, so you have a right channel, I think, but it's a little far away from the manufacturing or industry we're talking about today. So maybe next time, would you please try to how to use your technology to help the workers or operators in the industry try to understand the learning the language from machine, maybe how to help the people and the machine to get to learn with each other and to collaborate with better with each other. Okay, so I just asked this a question. It's for teaching. Okay, now. Club time is out. Now it's 5:20:22. We have 10 minutes to have a Q&A session. And Guy, please stop your video so that we can share the speaker's face. I would like to ask the audience who would like to give you a question at first one. If you'd like to raise your question, please unmute yourself so that we can learn your voice, please. Is there anybody? If no, I would like to invite Professor Carlo to give a short summary or give some comments about the 4 startups. What's your opinion about their performance today?
Yeah, also all the presentation were very, very interesting. And from an industrial point of view, as I already said, mainly the use of image and video processing give rise to a very huge set of application. It is also very interesting the application of detecting the correct configuration of the Kinder snack. My son always eat this snack. So when he open, I try to see if there is the right quantity of chocolate inside. So it's very interesting, and obviously a problem that maybe was not very addressed, but only appeared in some presentation, is the problem of explainable AI, in the sense that maybe in industrial cases, in some cases, there is not a significant need to have a system that is able to explain its decision, because mainly in case of, for example, industrial application, we saw in this case it is important, obviously, the overall accuracy of the system, but anyway it's not a big issue. On the other hand, for example, in medical application, there is very, very important, and also all the problems related to a trustworthy AI is also related to have the possibility of having an explanation of the AI decision. So in several cases, this is surely a big issue.
Yes, okay, thank you for your appreciation and also your valuable comments. Now I see there is a audience, Mr. Su, if I'm correct. Could you unmute yourself so that we can see your question? Su, please.
I had a question regarding to the last presentation.
The last one, right? Yeah.
Yeah, it's about an AI application to help, I think, help foreigners outside China to learn Mandarin, right? I think
yes.
It's only for learning Chinese. Are they going to launch the program? I think it's intended for the people out of China, because you know it's the trend for people to learn Chinese now in this new.
Yes, the founder of the last one, could you share your answers to this question?
Yeah, sure. Yeah, so indeed it is the trend. In fact, the number of students learning Chinese around the world is growing a lot. So it's forecast to reach 200 million students in 2025. So we specialize in Chinese, but also we launched for English and learning Spanish, because especially because of the COVID-19, many schools are asking us to develop that solution. So we're pushing really hard in the past few months to do the other languages. So our solution right now is to learn those 3 languages, but we are building this multi-language architecture that allow us to scale to other languages quicker.
When do you think you will launch the app? Because
it's already launched. It's already launched.
What is the name? of the application?
edugo.ai.
Oh, it's a website.
Yeah. So maybe you can send me a message in private, and then we can talk later if you want.
Oh, okay. How can I write
Yeah, I
you
will
an
send.
email?
Yeah, I will send you in the chat here in the Zoom, and
Oh, okay. Thank you.
Thank you so much.
Giuseppe, right? Okay.
Yeah.
That's great.
Hopefully-
Thank you very much.
Hopefully you can get a potential customer, and if you get the deal, then you make deal, please give some commission to CI-LAM, okay? For our educational fund, okay? Yeah, please don't forget. Yeah. Any other question from our audience, please?
Yes, can you hear me?
Yes, please.
Just have a very small questions to Dr. Li Miao.
Li Miao, could you show your face again? Because people want
Yes,
to
of
find.
course. Yeah.
Yes.
In your presentation, you mentioned you use autoencoder and classify to classify to detect some objects in your images. So I'm wondering why you choose this combination. I mean the autoencoder plus extra classify, rather than use a common solution like a convolutional neural network for one-shot detection.
There are several reasons for this. Actually, the first reason is that for the labeling of this food, or especially for mushroom and a lot of other food, it's quite subjective. It's actually not so objective. When we say this apple is good, this apple is not good, actually we cannot give a very clear borderline between these two labels. So for mushroom, actually, we noticed this problem, and then we use this encoder actually try to learn this underlying I would say, very confusing features by itself. So this is one reason. And another reason is that actually different end customers, basically different factories, they will have their own logic to classify this mushroom. And for this factory, they will say, I want this be the mushroom A, this be the mushroom B. But for another factory, they have totally different criteria. So if we label it one by one, and we train the model for factory A, and also we train another model for factory B, and this is so time consuming, and it costs a lot of time and a lot of data collection. It's not so good, and it's not so economic. So in order to solve this, actually we just collect all the data from different factories, and we try to learn this, give the minimal labels, and try to learn this. It's kind of like a very like unsupervised learning, and this we can learn this the hidden features, and with these hidden features, and then we connect it with the last layer of this. Then we only need to change the last layer of this neural network with actually the criteria of the end customer, and then our whole application become scalable. Right now we have deployed more than like 200 different suite of this mushroom sorting system all over China, and actually all the mushroom basically in China are sorted by our system. Yeah.
Okay, thank you very much.
Yeah, thank you. I think a scalable and modular software and even hardware laboratory is very initial for your sustainability. Okay.
Yes.
Not only deal with mushroom, but also other difficulties. Any questions from other ones? If you want, you can raise your hand so that I can notice you. Yeah. If no, I would like to leave 2 minutes to our startup representatives. If you like, you can raise your questions to each other, because it's not a very easy way for you to have a chance to get in together at this stage. Okay. If you have a question towards each other. No? Okay. Since this topic is only for AI Industry 4.0. I would like to give a prediction to our next seminar, which is the number 5 in our series. The next seminar is talking about the collaborative and autonomous robotics for the industry of the future. And it's quite related to the topic we are talking about today, but it's from another point of view. The date will be 17th July, which is 10 days after. And the time will be in Italy time from 9 to 10 a.m. I think 1 hour is not enough for our full contents. So I think it could be 1.5 an hour. And in Chinese time, we will start at 3 to 4:13, okay? And if you have a further question, you can also visit the website of CI-LAM, www.ci-lam.org, and there are more updates and news and also future plans, even now including our factory future of the TechX, which is towards the graduate and the PhD students from the university. So now it's the end of today's session. I would like to share my show my thanks to all of you, Professor Carlo, and all representative founders and CEOs from 4 startup companies. Thank you so much.
Thank you very much, Jason, for your moderation of this day. I want to underline that it was a very, very interesting webinar. It's a very interesting approach for all the people that speak, and it's another very important success of this webinar series. We are improving day by day, and we are very proud to make this for all the startups that we have with us. Thank you very much to all the people.
Okay, I would like to remind all of you that the big guy just now is Professor Giovanni, who is also the founder of the CI-LAM. He came from University of Naples, Federico II. Okay, thank you, all of you.
Thank you. Thank you.
Yeah, bye.
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 Have a nice day.
Bye. Bye, Carol.
Bye.
Yeah, bye.
Very much.
You.
Thank you very much.
Thank you.
Bye.